morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Eugenia from Business Review, and I will be your host. It's our pleasure to have Dyson with us today, who will be presenting this webinar titled Floor Surface Contamination in Controlled Environments. Today's guest speaker is Carlos Morel, Sales Director at Dyson. Now we'll provide some housekeeping information before we start. First of all, I would like to welcome everyone to our webinar platform On24. You will notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the Q&A widget. Just type them into the box at the top right corner of your screen and click Submit. We will allocate some time at the end of the session to address any questions or thoughts that you may have. Even if your question doesn't get answered today, it will be available to be answered at a later date. You can download and review different types of resources connected to this topic of this event at the bottom of your screen. In addition, we have two short polling questions today. To vote, please select the answer relevant to you and click Submit. Each poll will take about 45 seconds. And now, please allow me to welcome Carlos Morel. Over to you, Carlos.
Thank you, Eugenia. Good day, everyone. And thank you in advance to all different time zones today for committing to the webinar. Quite frankly, quite overwhelmed with the response so far online, and so extremely honored to present something that's a topic, opportunity for me to present to new and existing connections today. As the title suggests, we will be discussing the risks of floor surface, the impact it can have if it goes if it doesn't, if no attention is given to it, and if so, what dedicated control, if you do decide to control, can have in a controlled environment, altering potentially the mindset that you have on this surface as a whole. As you said, my name's Carlos. I am one of the senior sales directors within the global Dyson family, and just a brief overview that we have several entities spread all over the world, in the USA, in Southeast Asia, and an extra setup in Europe as well. And Dyson itself, I'm based in the UK. Dyson itself is going to be 60 years in a couple of years' time, and I will at that time have been around for a quarter of its life here, and for most of my adulthood now have been examining, looking and touching floor surfaces. So I have a personal attachment to this topic, and I hope today I can convey that engagement and conversation into its risks and the control available from us in particular. Okay, so some of the objectives here that we have outside of engaging with a new curious audience on the topic, I hope, is that we're going to explore the element of floor surfaces and its largely relegated status across surface control, particularly against sister surfaces outside hand and touch surfaces that are when it comes to transmission of risk and cross-contamination. Through that, and knowing its impact, we hope that we can express floor surfaces in an equal weight when it comes to decision-making at a contamination control process, and if so, what control methods are out there to support and reduce that risk at source. And with that, aid a mindset change. What I mean by mindset is not necessarily a negative one out there, but essentially there isn't one. It's due to its relegated status in most cases. The mindset is reactive. So I hope today through case studies later on in the webinar, which show customers that have prioritized floor level contamination, you can see a more holistic view of how this surface can really impact your contamination control processes in a good way. Those who know me and those who follow my posts online will know that I don't take myself too seriously. The topic is quite serious enough, and I am I have a commercial background, so I'm not going to pretend that I have a scientific one today, although there is some gravitas due to experience at this level. There are clearly, even possibly in this audience today, much wiser and more educated people on this topic that can provide much more knowledge transfer outside of the 45 minutes or so we have today. That said, my approach is more learned by doing. So I'm hoping that at least on this platform we can share across these 5 points, mostly a context to share moving forward on a topic that is less known compared to other surface contamination literature or studies. Make it transparent for everyone, try and make it equal for everyone. There are different settings out there. Not everyone has the same need. So a wider, more cohesive argument is also something I wish to achieve today. Learn, again, I will always want to learn by doing, so hopefully this is engaging for you and the questions will come through there. And then as a result of this, like anything that is on this platform or anything like this, would be to create a deeper analysis and move this forward, move this topic forward further. At this point is when the next slides will be, what we will see next is 2 side-by-side polling questions. I kindly ask you to fill those in. It will give us some insight into how we maybe have to adapt this webinar in a live setting. And I believe there is an interactive survey also going through the webinar or after the presentation that I kindly ask you to complete. That is also for us to do our jobs better and tailor some responses later on. So I think now the first polling question is coming up, yes. Question here is a very simple one. What industry do you work in? And the options here are, if you have a clean room setting, please choose that one. If you just have a controlled setting, but not necessarily a classified clean room, that's your option. And then maybe you want to choose something more specific if it's nothing to do with controlled environment, but more of a hygiene, a zoning concept or hospital-related environment or other. Please select now.
And I would like to remind you that we have 45 seconds before we take a look at the poll results. Please select the answer relevant to you and click submit. Your feedback is important and we will appreciate your votes. You can start voting now. Okay, 20 seconds left. Okay, perfect. Let's see the results now.
Okay, thank you. Take those into account. That's great. It's quite a varied mix there, so that's perfect for what we're going to be discussing later on. So thank you. The second polling question, I believe if I click on the next slide, is what type of contamination control do you use in your facility at floor level? You have the first 4 actual maybe products or examples of alternatives that you may use or have used. And then you may also have a mix of things depending on the environment, or you may have nothing or using nothing at the moment. So any of those questions, any of those answers will be relatable to today. Thank you.
And again, just to remind you, please select the answer relevant to you and click submit. We have 45 seconds before we take a look at the results. Okay, let's take a look at the results. Oh, excuse me, Carlos, you're on mute.
Also saying thank you. That's, again, quite a varied mix, so appreciate the input. Okay, with that in mind also, we move on, and as I'm going to turn off my camera from a practicality perspective now, come back to you guys towards the end on the Q&A and the summaries back online from that perspective. So thank you again, and hope you enjoy it. The agenda itself is planning this out. We focused on what we call the 5 S's, and the first one we look at the story, i.e. some of the literature, the trends, what is out there on this topic, and whether we are looking at data that suggests an emerging trend on floor surface cleanliness as much as importance of floor surface, what is out there in practice as well. Merging into this will be the science, mostly logical theories and explanations as to why realistically floors as a surface should be more dominant in people's minds when it comes to controlling contamination or thinking about a process, a more holistic contamination control strategy, including the floor. We will then look at the sense, which is basically common sense, and looking at the perspectives at floor level, what contaminants there are, and the impact and scenarios depending on the industry setting. We'll go through some diagrams here and explore some cases, which then will take in turn a little bit more down the suggestive routes of how you can create a contamination control solution at floor level to support your needs. And we will be focusing that mostly obviously on DISM contamination control flooring solutions. At the end, there's a statement, a summary, a moving forward concept that hopefully where there's some mindset alterations by then, even if minimal. But you know, what influence will this have when you look at your next contamination control strategy in context to the floor? So we will go through that then. Okay. We cannot look at the story without looking at the his story. So excuse the awful pun there. But essentially, outside of just increasing awareness here, what we want to do is not discourage or focus too much on what has not been focused on in the past. Clearly, floors have had, there's literature and there's data to suggest that floors are, are a surface for one. They get contaminated for two, and there are ways to, and there's a lot of data there to support how to maintain a floor to keep it clean. The argument on our side today is that there are a lot of gaps from how the prioritization at this level versus other surfaces, or even as in equal measure to other surfaces when thinking of a contamination control strategy. So try and go through that a little bit without hopefully upsetting too many people. But yeah, historically, there's quite a limited data on this subject. If there is data, it's quite repetitive from an aspect of hygiene and disinfection, or it's steeped in subjectivity from a commercial aspect, in the sense of it's steeped in a focus on infection control or viral outbreaks. So obviously, most recent scenarios will attest to that. Then there is a specific part of literature that's either focused in a clean room setting or in like an environmental, like a home setting or hospitality. So there's not a lot of data in between to suggest that we can pick something up from the past. More and more now there is, as we've come closer to the year 2000s at the bottom, we see that there is more emerging platforms and regulations in place that highlight floors more impacting. But until then, a very heavy microbial context in the literature as well, negating the fact that sometimes it's not always to do with microbial risk at floor level or any surface level for that matter. So that kind of takes away the importance in controlled environments where maybe dust is the most important thing outside of any bacterial or pathogenic risk. Clearly, what is very steeped in history is that there is a widely recognized role in hand and touch surfaces, especially for pathogenic transmission. I mean, that's quite logical, and no one's contesting that. However, it's less clear what role, if any, really floors played in that transmission alone. Until really the early 70s. That kind of gives birth as well to the clean room setting, so it does make sense when literature and data started to emerge, suggesting that at floor level, there can be a redistribution of bacteria into the air, which could account to up to 15% of all airborne bacteria. That has been developed further as well, and we have our own independent studies at Dyson to highlight a range between that and 75%. So we know, thank you to some of that literature there, it's moved on a little bit. And then linked to this, we also find that there is data to suggest that cleaning, as important as it is and as frequently needed, it's maybe not sufficient in some cases given the rapid rate of recontamination on such a large surface and complex surface as the floor can be in any environment. As we moved closer to the early 2000s, this is where maybe we had a clearer picture of floors in a more closer to a more important setting as a surface, and we found, we would see that it would act as a vector for redispersion. And that people would start talking about particle shedding and dust dissemination, transfer from the floor, and the risk of pathogens coming from the floor to the air were more established by then, and so forth from now on. So the academia in the past is quite archaic, limited, and developed, and not really developed outside certain settings. It remains still a generalized, relegated entity in its influence, personally, versus other surfaces. And there are many settings and regulation that are not quite clear or class it as a non-critical entity still. So that creates a lethargic mindset in people's, obviously in people's minds and actions when it comes to floor surfaces. In many settings, and much of my experience so far, is that floor control tends to be a choice over an action. Those who do choose to reverse this mindset, however, do see gains, but it does remain, both in literature and practice, quite an inferior surface to focus on. Yes, clean rooms in particular do apply more control here, and we see that in emerging support with ISO guidelines, particularly ISO 14644. At least in the clean room setting, it actively now encourages more monitoring of surface cleanliness of floors in equal weight as things like work surfaces, tool surfaces. So it is demonstrating a movement towards more importance. And hopefully, that trend can move past just clean rooms. And we can see now in GMP, the new release of GMP Annex, for those who are familiar with clean room standards and sterile standards, there is a need for a more holistic CCS, contamination control strategy in place, which needs to bring into play cleaning and surface control anyway. And there are always other regulatory bodies, particularly in food and healthcare, that summon that same understanding. Okay. Now on your screens, you should see an animation run, which impacts some of the risk of an unprotected floor that can pose to a facility. You can see volume of traffic and different loops and types that can generate an increased risk of particles if not controlled or contained. The nearest surface for any particle to rest on will be the floor in most cases, and is generally the largest, with 80% of contamination coming from the floor alone into past an entry point. Therefore, there is a high risk that it becomes a vector, especially wheels and people traffic, and that creates cross-contamination risk. I'm just going to let that finish. I think it's finish now, perhaps. Yeah. Okay, so that animation and that video takes us to the science. And really, when we talk about science, we're talking about simple logic. The diagram tells us everything. if the majority of contamination comes from your floor and you don't contain it, there's a risk of dispersion. Generally, the largest surface area sees the least control in any controlled environment, even including clean room environments from practical experience. Cleaning alone, specifically as you get more critical, is not enough. And even if you are meeting basic requirements of PPE, potentially overshoes or dedicated clean room shoes, eventually they themselves become a vector to worry about, because you are transferring from the sole of your foot or the wheel contamination into a cleaner environment. This 80-20 rule is something that is more frequently seen. So most users tend to spend 80% of their time and effort on 20% of the problem inside. Most contamination control setups that we see, or that when we go and visit, are dictated down from regulation or from a feeling that is the best way to do it, or that's the way that it works. And as such, sometimes, have flaws in their cost center. Most contamination control strategies we tend to follow versus lead, and that generates an element of lethargy in the analysis of how to properly control at source. Clean rooms or any controlled environment, any clean area, is generally quite expensive to run. So imagine how expensive it is to get wrong. And many, when they do get wrong, will panic and focus on that 20% of surface inside, spending 80% of their time on it. Therefore, a reversal, potentially, not a full reversal, but a mindset change and looking at the problem outside might yield a more sustainable long-term gain. So from a simple perspective, the science shows that we should maybe look at flaws at a heightened level of importance. When we go into the further logic, again, there were mentions in the literature about shedding, particle shedding, Brownian motion, the movement of particles, all these kind of things. It all adds to the same problem that people or machinery or wheels or vectors, particularly people, are the problem when it comes to contamination. So it's a tested fact and a kind of unavoidable one. Shedding itself will vary in risk, obviously, depending on the environment. But regardless of that environment, you are going to have a risk of dispersion in high frequently change in high traffic areas. So outside of hand and touch surface environments, which quite rightly you need to focus on, shedding or particle movement generally occurs during a change area or a high frequency transfer area. And in most cases, it's when people are changing to get cleaner. So the irony about that is that we're changing to get cleaner, but we are dispersing at that point probably more particles than we would in a normal setting. So the likelihood of a trifecta of Brownian motion in that environment, airflow changes, if you're lucky enough to have airflow changes or positive airflow pushing particles down to the floor, essentially, or particles are heavy enough at a micron size to be able to just fall, or suspended particles that get pushed down or attached. You're going to get a risk of all that transferring and dispersing from the floor up or down onto the floor and into a critical area. And that can range from anywhere, as we've seen, from 15 to 75% recontamination from the floor into the air. So I'm not going to say it's science, but I think it's logic that leads us to think that if we do examine this surface a little bit better, in a better light, with a bit more thought and a bit more application, that we can really look at models and control systems to allow us to benefit from reducing that risk. A control essentially at source will significantly reduce that risk and then prevent cross-contamination from happening. Okay, this slide is clearly a collage of different flooring, different vectors, I suppose, different layouts, but many of these represent some of our weekly visit schedules for myself and some of my team members. It will depend on the industry, it will depend on the criticality, but clearly in many of these pictures you can see how the floor can act as a vector of dispersion, mainly due to the traffic flows in there, the amalgamation of wheels, the cleaning itself, and the sources of entry for risk. A lot of these are obviously slightly more outside of the controlled, maybe of the clean room or of the core nucleus or of the critical area. However, the further out you get, the less control is present. That is absolutely fine if there's control and containment at floor level closer to the critical area. If there isn't, what you see in these pictures is going to eventually at some point in some capacity and some percentage end up closer and create that risk. So that slide started us with the sense and the common sense of things and perspectives. We only really see about 3% of the risk in terms of contamination. So contaminants, 97% of all contaminants are invisible to the naked eye, and will largely be contained within a larger particle, i.e. generally dust particle. So they come in a different range of micron sizes, and the majority of contaminants that are attached to dust and debris will find their way past a suspended status onto a settled status onto a nearest surface. If it is the floor, which 80% of the time it will be, it will amalgamate, it will grow, it could grow, it will harbor and transmit those contaminants without a barrier to affect them. So the risk of many of these is inevitable. And you know that the 5-second rule that may apply in your kitchen, or apply certainly to my kids when they drop something, may not apply so much to a production environment, I wager. This is a very interesting slide. It's looking at the contaminants, but from a micron breakdown perspective. And one of the things here that it illustrates is that it doesn't really matter whether you have a clean room setting or a basic hygiene zone or controlled environment. The range of where dust works and what it could potentially carry up from a visible micron size from 100 micron down to almost here, well, down to 0.01, but at least that 0.55 micron range within settling and suspended dust. It's where really all that microbial risk can attach to it and break down and travel. Depending on the status or the required control, dust is something that really we should look at source, and really we should look at floor surfaces as a vector for that dust as much as other surfaces in equal measure. So that's quite a good slide to see that. A different way to look at it is looking at risk at floor level based on break down the particle focus by area and industry. So, you know, visible risk, some of the visible risk up to about 30 micron, I think, to the naked eye, to a good eye, you'll be able to see. Anything below that is invisible, and that is, you know, that's where we focus more on critical clean room environments, sterile environments. And you can see then once you get into a more controlled area, you are looking at controlling more of the dust particles. But the key to all this is you cannot generally reduce the invisible without containing the visible beforehand. So everything works in tandem. I don't think there's physically any way that you can control invisible risk without first controlling visible risk somewhere else in the process. Okay, so far we focused, when we looked at mindset changes and how to show the impact at floor level, you know, it's very much down to the person, or it's very much down to the regulation and dictated, but sometimes it's equally subjective that there are different product types, different production types and layouts, and these factors play a big role in how we assess floor risk and the impact of it, and should we look at a floor control method to support it. Those who have been, when I've been at Dyson, those who have been with me for a long time and have had previous Dyson training, and certainly those who have had a visit from me for a new consultation will know of my affection and love for this onion concept. Since I started at Dyson, I've been a huge admirer of Dr. Tim Sandel's diagram, and fair to say that unashamedly I have plagiarized it so many times in training and consultations that it's just become part of my routine to support different risk scenarios and the impact. And what I'm going to try and do today is visualize this for 3 different settings that are all in some way have some commonalities, but are very different in the need for flow control. 2 drivers, especially when I look at flow impact scenarios, will be that a critical area is generally at the center of any business. It has to be the hardest area to get into. It has to be the furthest away from outside, generally, because if not, it wouldn't be that critical. So by default, everywhere, regardless of a clean room or a controlled environment, you will have a core, and that is illustrated by the center of these onions. One clear certainty then is that there are layers around that will depend on the criticality of each site. But never undervaluing, it doesn't matter if you have less layers or more layers. Just because you maybe don't have a clean room doesn't mean you have a clean area. It's just sometimes you will have different layers depending on the production in that facility and the criticality of it. So if we did slice 3 environments here, we would find we'd have different layers with different protocols, and more defined the closer to critical areas we get. The one certainty across all these is that the constant surface within any layer or any entry between layer is the flow. So without control or without understanding its value and due diligence perhaps, cross-contamination risk is very likely at flow level. And we will show that in the next slide. Bear with me, there's a lot of text on this one. The red emphasizes the spread of potential risk, and that general risk is always driven by volume of traffic and the fact that it has come from a layer before it, and in most cases it has come from the outer layers. Similarities of the spread are very obvious regardless of the environment. And you can look at this from a visible to invisible risk perspective, linking back to the previous slides. Generally speaking, finer particles, any invisible risk of a micron level cannot really happen unless there are larger particles affecting that close to the critical area. So again, this also takes into the fact the mindset of looking at the 80-20 rule as well when thinking about a contamination control strategy and looking at how you can yield a more positive gain if you look at a more holistic picture. So we'll look at the areas. The layers themselves, one is clearly a clean room setting, could be pharmaceutical, could be production or contract manufacturing, solid dosage perhaps, and then obviously vaccine production, life science, those kind of areas. An ISO 5 would dictate pretty much a sterile environment. So if you claimed or anyone claims to have an ISO 5, generally doesn't have any more layers until they get outside of that production without any control, I don't think you have an ISO 5 clean room. Therefore, within these settings, there's a lot of regulation, there's a lot of process, and there's a vigorous routine of either multiple air changes to support the transfers of containment and particles, and also then a personal protective equipment process and routine to protect surfaces and entry points, generally through dedicated airlocks in each layer. So as you go from a controlled, not classified area, potentially the warehouse, up to ISO 5, you are likely to have bands of ISO 8 to 6 working in conjunction to make sure that the containment is accurate for working in that ISO standard. Generally, there's a microbial risk attached. That's why they focus on the 0.5 to 5 micron ranges in most audits and pressures externally. But the idea is that it has to come from cross-contamination outside, and a lot of the larger particles that we tend to work with in these settings would be powders, cross-contamination of powders perhaps in pharmaceutical, and especially from the high output now of wheel traffic, if there's also packaging amalgamation in play. The second onion is more of a controlled environment, and in this setting, a non-microbial one. One where we focus on ESD settings. And again, doesn't necessarily mean they could have more layers than this, but in general, you are talking about a few layers between non-ESD and ESD. That is the cutoff. So generally speaking, you are talking about dust particles and the reduction of dust that carry static in or ESD contamination in to a clean area. Therefore, like clean rooms in some way, you have to look at controlling that source. There's a heavy volume frequency in these environments. PPE is also encouraged. Floors are looked at, but possibly less compared to other surfaces. And generally there is a routine at each entry point, i.e. turnstiles or changing areas to support the layers. So the impact there is still relatively big, and actually harder to contain because there are less layers and larger particles that have to be controlled between those layers. And then the third one, we've just dissected from control and focused on, in this case, a low and high care food environment. Again, generally speaking, there are less layers. Unless you are a nutritional company, you're more inclined to be towards an ISO standard onion scenario template. But from a food perspective, you will have a low care zone going into a high care zone. So there will be things like wash stations, station areas, sanitation, communal GMP zones, and within those zones you are looking to control large particle transfer at source to support and reduce the risk of microbial cross-contamination. So although they are different, although they are completely different industries, although they maybe need different controls for different contaminants, the kind of pattern of behavior at floor level is quite similar. And depending on the amount of layers you have, sometimes the more layers you have, you can control that a little bit easier because it's more dedicated. But if you don't, you need to look at solutions at floor level as well, just as importantly as those to control finer particles. So again, we go back to the diagrams themselves. And when we look at the scenarios in the last slide and the need, we equally, if you are looking at a floor level control solution, you need to customize that control because it is also subjective to each type of onion. Most people who look at floor level or maybe have used alternatives, or I saw from the poll that some people are using XYZ in different settings. You may use sticky mats in some of these, but you will also use foot baths, I imagine, in a food environment more. Floor level control, even if you are using something, is still quite relegated in the reactiveness of doing it right. And the reason for this for me is because well, three reasons. One, there's a lack of knowledge that's out there to help. And what I mean by that is sometimes people don't know, well, we exist, or people just simply don't know there are alternatives that exist outside of maybe the industry standard or the habit that is being dictated down. Then as well, the second reason is that there are inferior alternatives out there that have been used and haven't yielded a positive impact to your mindset. Therefore, you are back to square one on that concept. And three, you have this ability to create a contamination control strategy, but it's not holistic enough to focus in equal measure at floor level. So there's a panic situation, and you focus more on spending inside on the 20% rather than the 80%. So those kind of three factors intertwine. And those who don't, or those who do look at floor level control in a more detailed way, may come across something like this. And these are just examples, some in similar fashion, of how you would implement floor level control using Dyson in particular, naturally. So back to the same industries in the onions. In a clean room setting, well, you have what we call a waterfall effect, and that's driven by the ISO layers. The benefit of having areas that naturally get more optimized and more sterile and more clean allows you to contain better closer to the critical area. So most layers will have dedicated zones for this, and you can develop a contamination control practice at floor level that is completely customizable for you, but still factoring in that you need to look at something a little bit closer to source to support those heavy particles prior to getting into each band, because each ISO level will dictate a particular CFU count between that 0.5 and 5 micron range anyway. So anything above that, is a no-go. Moving into the middle section, ESD areas can vary again, but similar in application, but again, you are not looking at different ISO levels in most cases. You are looking at, I have a non-ESD floor on one side of the room, and then I go straight into the ESD side from maybe packaging into production. And this is depicted here where you have, again, a larger floor level control at source within a warehouse capacity, perhaps supporting the wheel traffic and the high volume dust traffic, should we say, the visible risk. And then within the entry points to the ESD zones, because of the nature of the facility, if it's a semiconductor, if it's an automotive, there's high volume traffic in these areas. You will have turnstile setups where you have areas of entry for everyone, and in that process it's quite symmetrical. So these are not necessarily the answers to everyone, but these are just practical references from what we have seen ourselves in our consultations. And moving on to the floor concept, here's a little bit different, but again, less layers mean you are looking at controlling at source quicker or closer to the critical area almost. Therefore, you look at communal GMP zones. You look at larger station areas where there's maybe an entry and exit. Sometimes a dual code system here where you have wheels and people going through the same area. And then you enter hygiene zones, you enter traffic light systems. So you might have a green, amber, and red redistribution depending on criticality. So we tailor that product and maybe overlap certain layers because of the nature of how close the high care zone is to potentially outside in some sites. So, but everything at the bottom here, as expressed in bold, is you're looking to control at source to support the rest of your critical environment. Okay, suggestions. Suggestions based on DISM. So within a cleanroom setting, here are some examples of what we would look at. We saw some transfer bays, we saw dedicated airlocks. You can see here we would use our fixed clean zone systems in most of these settings to support cross-contamination between ISO bands and ISO layers. Any particles that are suspended within airlocks would fall to the surface or through the filtration and push down, and that would allow particles to be collected prior to a more sterile entry. On the right side, you have a very common granulation dispensing corridor, CNC corridor into ISO 8, where actually the risk of cross-contamination is at both ends, one to go in to support containment of particles, and one to come out to reduce the risk of cross-contamination from pallets between multiple lines of contract manufacturing and multiple powder lines, for example. Clean rooms are generally quite similar, but there are areas to suit all onions when it comes to DISM, and in some cases it depends on what the core need is. So on the left, on the first picture, you may have a packaging suite where it's blister packaging or primary packaging, so the need to have an optimum size, customized size to support wheel entry prior to going into an ISO 7 perhaps would dictate something like this picture here. The picture on the far right is quite similar as well, going into a sterile suite where you have clean trolleys, dirty clean trolley swap overs, and you need to make sure that the particles are contained prior to entry. And the middle one is more what we talked about earlier, where you have this particle shedding and in these high frequency change areas when you are changing to be cleaner, you have to, particles will fall to the nearest surface. And in a setup like a changing area, the biggest surface there on that picture is the floor. So anything that is suspended post and during the transition, anything that falls onto the floor with Dyson will get trapped and collected, and then through a maintenance program and a disinfectant routine, you will reactivate that surface by cleaning it off and moving on and going forward from there. So always active system. Moving on to control settings. Sometimes they don't differ in terms of location, but here you may not have those ISO layers, so you don't have maybe the air changes or the positive airflows depending on the environment, but you do have changing bays, or you do have transfer areas between dirty and clean side. So the idea of a system at floor level is to be centralized and for it to become unavoidable for any human error or anything that can maybe be at risk from going from one side to the other. You can see these pictures quite clearly. It shows dirty side implementations to support that large particle transfer, that containment of maybe visible risk prior to going into a controlled environment, whether it's an ESD zone in non-microbial settings as much as a microbial setting here. This could also apply to healthcare, could apply to other sectors, animal facilities as well, for example. From the ESD side, we mentioned earlier the turnstile kind of effect. Well, here they are like a clean room. They have a dedicated entry to support ESD. So Dyson in particular is adaptable and implemented within that turnstile concept to support the large volume. The sizing is to support the large volume, and then within that to be the closest to the ESD area to really support that dissipative control or conductive control if needed, if you need to neutralize the static prior to entry. In some ESD environments on the right, you might have a goods in area, and that goods in area, the moment you touch that really close to that layer of that onion, you may have an ESD zone straight away. So this is more about controlling that source where you might have a buildup caused by obviously dust and debris. 1 or 2 wheel rotations prior to entry can really support an ESD area that's very close within a packaging production or warehouse production. Depends on the size of the company and the layout, of course. And then in food, food or hygiene, high care settings, you're always working again with confined spaces, and you're working with an area going from low to high where generally there is a change, and that change will be either a step over or a booty change, especially in dry foods, or you're looking at a sanitation area where you are embedding our flooring model to support hand wash stations prior to a GMP entry zone or prior to a more dedicated high care zone. Colors are very popular when it comes to this area to support in red and green, perhaps to highlight a behavioral change as much as anything. But again, because you are cleaning and disinfecting these floors anyway, minimum of once per day, Dyson is completely adaptable to an SOP system within this environment and visually allows people to see that there is a barrier prior to entry. So I promised I would come back online. Hello. For the statements, for the takeaways. And these are kind of what it's just a summary of things. For me, the flaws, or what we should see is that they merit a wider, more comprehensive value, and in that value an equal part in the process of deciding on a contamination control strategy, given the impact of flaws at different levels. If you do apply a control factor at floor level, you are going to get an exhaustive list of benefits if you control both where you have to and also at source to prevent that large particle transfer. As a vector, clearly it's a priority area, especially for wheels, and I think there's not a lot of data on that, so we need to really look into that more as a takeaway for future research, perhaps. And we work with case studies and references to support that, but that's something that needs to come out into the wider audience. And then this ability, I suppose, to make the change of mindset to be more proactive, to be more holistic when you are deciding, not wait till the last minute or to the last penny, if that's the case, to implement a floor solution and then implement it wrongly. Implement something as part of your control. Within that, then you will find that if you do that, you will have a far more sustainable 80% solution than the sole focus of controlling post measures in any critical setting. So those who have, and the pictures that you saw earlier and the references, those who have implemented some form of DISM, they've done so because they've used nothing before. They've done so because they've used other alternatives before. And once they have looked at a solution that is optimal and works and is adaptable within their system, they have seen that they have created an unavoidable solution that has allowed them a simple and long-term effective reward in their procedure. So from me to you, please, I think there's a way to save this webinar. If you can't save it, we will send it to you, and I think there's a process there. I am one of many people who can help you, so please hit up our websites, especially for more industry content or product content or specifics. I didn't want to go into that too much today because it was more about the awareness of the context rather than offering you a sales pitch today. Our website is very interactive, and then from there there's an interactive map as well of the people who you might be able to connect to. If you can't, just come back to me, but if you can, book a specialist in. That's what they're there for. They will then come and do a presentation, of course, a practical survey, and I encourage everyone to take a no-win, no-fee test trial. Because as a concept, if it's new to you, you need to visualize it, not just to see that if it's if it's an important surface for you, but to prioritize it for future reference. So all these things we can do to help you, and I do encourage that. I think I've gone a little bit over with the introductions, but maybe there's some questions. What we will do, so thank you, absolute pleasure. My details are there. And I think now maybe some Q&A, if I'm not mistaken.
Yeah, thank you very much for the presentation. And just a reminder for the audience, in order to ask questions, you can send them in via the questions widget. Just add them into the box at the top right-hand corner of your screen and click submit. Please note that you can still send your questions after the webinar, and they will be available to be answered at a later date. And I would also like to remind you that there is a short survey that we would appreciate you to fill out at the end of the event. Please find the survey at the bottom of the screen. Okay, and it looks like we've got several questions already. All right, okay. So so our first question is, how easily would floor control such as DISM adapt to a CCS routine?
Yeah, okay, that's a good question. In essence, it's very easy because the concept in most cases or most of these scenarios, the floor is something that you have to clean anyway, and as part of a process, you would clean per shift or clean per day, once a day per minimum. And so our product is adaptable to an SOP quite easily. It is we are ISO 9001 certified and 14001 certified to support people's quality drives, and from a concept of implementation, it's a very simple installation procedure that doesn't affect any downtime, really. Maybe some shutdown period in that area to actually install it, but once it's installed, 10 minutes after, it's active. It's constantly active, and through a maintenance routine, it will you'll be able to use it for a minimum of 3 years in the majority of settings. So it has this sustainable factor as well that embeds into a contamination control long-term strategy.
Okay, thank you. And our next question is, what would be the complementary benefits to someone looking to improve contamination control at floor level?
Yeah, I think one of the things is, I think, okay, there's maybe three. I would say that if you implement DISM at floor level, one of the arguments is that because you are controlling prior to entry, usually you then have less you have less downtime in relation to cleaning inside. So that is a cost benefit in many ways, because there's less time cleaning a clean room and more time using the clean room. They're very expensive to run, and so by having controls at source and outside, you effectively are allowing yourself to create a more simple, maybe cleaning routines, which create a downtime benefit. The second one I would say is the airborne element. So we have had independent studies ourselves, but if you are trapping particles that normally you wouldn't trap outside of a controlled area, outside of a high care zone, outside of any form of critical area, what you are doing is you are then reducing the wear and reducing the effort that filtration or anything like that. If you have a clean room, you have air filters, you are reducing the wear of those filters. So therefore you don't have to, that's again a cost benefit. So you don't have to replace that part of the process as much, and then that will be an indirect cost saving. The third one then is looking more at the green side. From a sustainability perspective, we have a product that lasts for a minimum, in most cases, of 3 years in sterile environments and low traffic environments. It can go as far as 5. Therefore, given the CO, we have data to support that compared to some alternatives, our emission, our CO2 levels in terms of the waste factor, the cost factor, all those things are very beneficial as well. So they can play a great role in allowing you to think of how to save money indirectly, as opposed to saving, not spending at all on floor level and having more risk as a result.
Okay, thank you. And our next question is, what are the limitations of your suggestions? We're not perfect. So from there are clearly other solutions that people are using, and they may work. So in most cases, I would say for an optimal decontamination, you need to have a certain size of a product at floor level so that it doesn't saturate. So if you don't have the physical space available sometimes, and you only have a small area to be able to control, the problem with that is that it will maybe not last as long, and it might, and you do need to clean it more. So there's different variables that can affect then that it can be limited. Certain industries as well, we need to factor in that any floor, if it's wet or completely wet, will be slippery. But in some environments, particularly in the food environments, where there's a lot of wet foaming or wet cleaning constantly, there's a need to understand location and where to apply something that is essentially a dry system that you disinfect. So there are limitations depending on the industries. Mostly it's to do with size, that optimal size, and some things that are almost out of our control right now because of industry standards and practices that are being applied. So adapting, I think, if the mindset changes a little bit, and it is, you can see much more pharmaceutical process and thinking in other sectors now. We start to see ways that we can support and reduce those limitations for people. Okay, thank you. And our next question is, what would be your direction to someone starting to implement floor level control?
Okay. Yes, if they were new to the concept, then I would definitely take the approach of what is it that you're actually looking to control? Do you need to control something close to the critical area, or is the problem further away? And this kind of onion concept is quite useful, because you would look at your areas, and I would always suggest taking a trial, because then the trial would allow you to visualize where it's important. A lot of people sometimes do this blindly, and they do it because there's a pressure to do so externally perhaps, and they don't do it wrong, but they sometimes put it in the wrong place, or put an area that is almost too big that is needed. So you need to look at the optimum sizes. So I would always recommend that people speak to one of us, or if it is Dyson that they're choosing, have a look at what's right for them, and then go through the process of trialing and testing, because that evaluation doesn't just give them a visual benefit, but it actually gives the people who work there, they can understand why it's going in there, so their mentality changes. Cleaners are our most important friends. We love the cleaning staff, because they are essentially the people who look after it, and so they need to accept it, and it needs to work within their protocols. So therefore, all those things is about having a site survey, having a presentation and a consultation, that be open with us to see what you actually want from this. Is it because I have a problem, or is it because I want to just improve? And there will be a different consultation for each.
Okay, thank you. Our next question is, with sustainability a key driver now, how green is your concept versus other options?
Good question. If I compare ourselves to some of our more direct alternatives out there, or people that are using, in particular, sticky mats, peelable polythene sheets of plastic and acrylic glue, I think the definition of a sticky mat is that it's not very recyclable. It's not something that is good for the environment from a waste perspective. It's a very consumable operation. So when you use one, you use many over a day or over a month, and you're actually then removing when you peel it to throw it away, you're throwing away a ball of contaminated waste that, if depending on your environment, you might have some serious contaminants lingering on that. And then above all else, you touch it as well, and you have to dispose of it in a very specific way, which is a cost. From a Dyson perspective, it's more the longevity factor of our product. We manufacture ISO 14001 levels to support from a carbon emission perspective, and essentially we are a vinyl plastic family. So because of the duration of our mats, we would test them, we would service them every year. There'd be a process of renewal, of replacement, and then that material that gets replaced is, because it's cleaned, it's non-hazardous. So essentially it can be recycled into plastic, into a standard plastic recycling concept. So from that perspective, given its durability, and mostly its durability and the fact that you clean it and disinfect it, it should support the green elements quite well compared to others. Yeah.
Okay, thank you. We actually have time for one more question, and
okay.
Just a second. Yeah. How much particulate is able to get under the mats typically? How much care do the mats require as far as cleaning the top surface and the floor underneath? What is the recommended method for cleaning the tops of the mats?
Okay, I see that question on my screen as well. So there's a few questions in that. Thank you, Andrew. So I'll start with the first one. Dyson, as a concept, can retain up to 0.2 micron in size. That's what is scientifically tested to do. So under the mats, typically we work within environments that range from that, but also then from a larger particle perspective, you are looking at dust. Over a shift pattern, the overstrike rate on our product, as in people can step over the same dust particle and our footstep or wheel particle several times. Yes, it will get saturated. So back to a limitation, if it's not cleaned effectively or daily, that saturation will grow, and that dirt will get ingrained inside the mat. So the issue there is that it can control particulate up to a very high micron level, but if it's not cleaned, all that you are doing is creating a surface of dirt that is not allowing the mat to reactivate and work at 100%. So your next question is, how much care do they need? We make sure that at a site survey, we look at optimum sizes, because in some cases there are variables, whether it's weight, traffic speed, how you act in that environment, turn in, break in. So we need to look at that to avoid damage, to avoid physical deterioration. And then cleaning, it's a manual clean. It's something of a pre-saturated mopping system, clean room mopping systems versus other mopping systems. A disinfectant or a solution that is a diluted solution, and providing you're cleaning it in the same way as you're cleaning your existing floor, which in most settings it's per shift or at least per day, you will get a guaranteed reactivation on that surface. Some people, you're right, do sometimes just clean the top, and that's where the manual versus machine can maybe, sometimes machine cleaning is actually worse than manual because it only does necessarily skim the top. So sometimes you need to deep clean the product if that happens, and there are very safe ways without too many chemicals to do that, which involve steam cleaning and other methods to do that. But manual cleaning with water and a neutral disinfectant, quat-ammonium, IPA diluted to a certain degree, those kind of systems once a day, you will get, as long as you do that once a day, you will get a desired life cycle that was discussed earlier.
Okay, thank you very much. And just a reminder for the audience, you can still send in any questions while watching on demand. All questions will be available to be answered at a later date. I would like to thank Carlos for this presentation and Dyson for sponsoring this session. To the attendees, you will receive an email telling you how you can access the on-demand version of this webinar. You can access this through our website, which is www.pmi-live.com. We look forward to sharing further webinars with you, so please do keep an eye on the above-mentioned website. Follow us on Twitter at BR Webinars for daily updates and join our LinkedIn group, Business Review Webinars PMI. Thank you once again, and I hope you all have a nice day.
Thank you. All right.